Today I want to show you what the basic exponential function looks like, just so you can picture it in your mind, and then we're going to talk about certain elements of exponential function. So right here, I've written out an exponential function, 2 to the x power, and I'm going to go ahead and we're going to plug in these numbers, and then we're going to graph them. So I have some graph paper, and first we're going to make the chart. Okay, so I have my calculator here, 2 raised to the negative 2 power. So 2 raised to the negative 2 power, and that gets me 0.25. Remember, if you were to write that out and say 2 to the negative 2 power, remember that tells you it goes to the denominator, so that's a fourth, or 0.25. I can just put 0.25 right now and, just say, okay, in my mind, I'm going to keep everything as decimals. All right, 2 to the negative 1 power is 0.5. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 cubed is 8. Okay. So now I want to go ahead and graph this to see what this is going to look like. All right, so when x is negative 2, it's at 0.25. Okay, so let's say right here, negative 1 is 0.5, 0 is 1, 1 is 2, 2 is 4, and 3 is 4. Okay, so you can see that this exponential function looks like this. And what is interesting about an exponential function is it's gonna keep, like if I went to negative 3 and plugged a negative 3 in here, 2 to the negative 3 power, 2 to the negative 3 power, it would keep getting smaller and smaller and smaller and smaller, but it's actually never going to cross that line, okay? And that's called an asymptote. It's when a function keeps getting closer and closer and closer to a line, but it is never going to cross it, okay? So that is what I'm gonna picture in my head when I think of an exponential function. And there's certain key features that I wanna make sure we go over. The first one is, I wrote this down so I would not forget the key features. The asymptote, and you would say, well, it would be 0 because it's going to get closer and closer and closer and closer to 0, but it is never going to cross this 0 line. Okay, the y-intercept. So the y-intercept, can you see? Yeah. Okay, so the y-intercept is 1. The domain. Okay, so remember domain is x. It means where could I squeeze this on the x? Well, this is going to keep going out that way, and this is going to keep going and going and going and going slowly up that way. It can also be whatever you're going to put in for the x, and we can put any number in for the x. So the domain is all real numbers. Now the range, so if you look at this picture going this way on the range, well, it's gonna keep going up, 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 up. So I can't cap it off here. And on the bottom, I can. It is never going to touch or go beneath this 0 line. So I'm gonna say the range is y is greater than 0. I'm not gonna say equal to 0 because it is never going to touch that 0 line, okay? And what is this graph doing? Now, I know some people will say, oh, well, it's going up here and it's going down there. It gets a little confusing. Remember, you always go from left to right. So if you wrote your name on there, you would say it is increasing. Increasing. Okay. All right. So here is the, here's how we figure out the equation, okay? We have f of x. The A is the initial amount. So if I was talking about an investment and it was increasing by a certain amount, which we're going to talk about another day a little bit more, but this is the initial amount. This is the constant ratio. And then this is how many like years or whatever is going by to tell you what the total amount would be. So let's look at this one. We're going to use this. We're going to use this chart. These are two separate problems. We're going to first look here. We're going to use this chart to get the equation, to get the exponential function equation. All right, so I'm going to start off with f of x. What is the initial amount? Well, if I look at this chart, it's 0, 4, 1, 12, 2, 36. So my initial amount is 4. Now I have to figure out my constant ratio. Well, what is happening? What is this, what is it increasing by? It looks like it's going up by 3. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. So I'm going to put times b, which is my ratio, to the x power. So if I wanted to figure out, and the nice thing about this is if we wanted to check it, let's say we weren't sure, if those were all right, we could figure out our pattern here and we could say, okay, well, if I plug a 4, right, if I plug the 4 for the x, if I plug the 4 into here, I should get 324. So 3 raised to the 4th power times 4 gets me 324. Okay, so it's just another way to just double check your formula. Okay, so here, same thing. We're gonna start off f of x. What's the initial amount? The initial amount's like my y-intercept, what's it's starting with is 128. And then because the x's are going up by 1, I can just say, oh, what's happening here? Well, sometimes it's a little tricky to find on these bigger numbers, but it should be consistent. So I noticed that 16 divided by 8, but divided by 2 is 8. So 128, and I want to think, what is it that I'm multiplying it by? I know I'm dividing by 2, but I'm multiplying by 1/2. So 1/2 x. And then if I wanted to just double check this, I could plug my 4 in. So here's my calculator for some of you guys that forgot how to do this. If I wanted to plug a 1/2 in my calculator, it's 1/2, a 1/2. Raise it to the 4th power because we're going to check and see if our answer ends up being 8 times 128. And I get 8. Okay, kind of just on the right track there. Okay, so now let's talk about if we actually had a word problem. And let's say there are 2 plans. Plan A is I start with $100 and it goes up $20 a week, or I start with $1 and it triples every week. So let's think about this for a second. With exponential growth, it was being multiplied by a certain number. Whoops, sorry. So let's look back at our chart for a second. Okay, if I look here, this was being multiplied by 3. This was being multiplied by a 3, multiplied by 3, multiplied by 3. This is being multiplied by a 1/2, multiplied by a 1/2, multiplied by a 1/2, multiplied by a 1/2. So with exponential functions, something is being multiplied the whole time. Linear functions, which we did before, is when we were like adding to, adding to, adding to. Okay, so $100 and it goes up 25. Let's see which plan is going to be better after let's say 5 weeks. Okay, we're gonna try to figure out which plan is better after 5 weeks. So let's look here. It starts off with $100. So at 0 time, it's $100. And after 1 week, it's going up $25. Okay, 2 weeks, it's going up another $25, up $150. 3 weeks, it's going up another $25. 4 weeks, it's going up another $25. And 5 weeks, another 25. So notice I said add 25, add 25. So this one is a linear function because it is not being multiplied. So after 5 weeks, I'm going to end up with 225. Now, if you wanted to write the equation, you would say f of x equals, remember my one-time fee is 100, and my slope, it's going up by 25. So that would be my equation for plan A. I'm trying to get a different color for plan B. Okay, so now let's look at Plan B. Plan B is a little bit different. It starts with just $1, but it triples. So tripling tells me that it is now being multiplied, right? Multiplied by 3. Okay, so we can go back and write the equation. We can do a chart too. Let's do both. Okay, at 0 time, I have $1. All right, so in 1 week, I have $3 because it triples. 2 weeks, I have $9. 3 weeks, 27. 4 weeks, 81. And 5 weeks, 243. Okay, so if I notice that it just takes 5 weeks for this plan that started off with $1 to be greater than this plan. Let's go ahead and try to write the equation. So f of x equals, remember that was a b to the x power. So when I put in, I'm going to say a was my initial amount, which was $1. B was the rate at which it is, you know, doubling or tripling or whatever. And then x is usually the time. Okay, so this is going to be my equation, f of x equals 3 to the x power. And I can double check that if we're just like, oh, I don't know, whoops. I don't know if that feels good. If I were to plug in here a 5, I would say 3 to the 5th power, and I get 243. Okay, so this is a linear function, and this guy right here is my exponential function. Okay, so we want to talk about this next part, the key features of a exponential function. So you can tell this is an exponential function because the variable, the x, is in the exponent. Okay, so what's happening here? If this number, because this is like the, if it's getting cut in half, if it's being double, tripled, this number is bigger than 1, then it's going to be growing. We know that our chart is going to be increasing. Just like the one we graphed before, it was going up, right? This was increasing. But if it's being multiplied by a number that's between 0 and 1, it's actually going to get smaller. So right now, I already know that this is decreasing. All right, if I wanted to make a chart, and start plugging in some numbers here. I have a half raised to the -2 power. That gets me 4. And in my mind, these numbers should be going down, right? They should be decreasing. Okay, a half raised to the -1 power is 2. So you can already see the pattern. It's getting cut in half, cut in half, cut in half, cut in half. So I can just go a little quicker here. Okay, so when I graph that, at -2, it's 4. At -1, it's 2. 0, it's 1. A half, a 4th, and the next one, you know, it's going to be like an 1/8. It's going to keep getting closer and closer and closer and closer and closer here. So when I look at that, key features, right? So some of these we can do without graphing. We don't want to have to graph everything. I can tell that it's decreasing already from what I had said from looking right here. The y-intercept is 1. And I could have also told that right here. I didn't really need to graph that. The asymptote is going to be 0 because it's never going to hit that 0 line. It's going to get closer and closer and closer, and it's never going to hit it. The domain is going to be all real numbers. There's no reason I can't plug anything into here. So the domain is all real numbers. And then the range, y is greater than 0, because this entire picture is going to be above the 0. Now, I didn't really have to graph that to answer those questions. I could have seen this pattern, having this chart does help. I could have looked here and figured out, well, it's decreasing, decreasing, decreasing. And then also, if I think about it, I might have been able to say, well, the asymptote has to be 0 because it's never quite going to get there. Doing this chart helps me a little more. Of course, the graph really does help me visualize it. But like I said, we don't want to always have to graph everything to in order to answer questions. All right, that's it. We'll practice more. Bye-bye.